Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in the Deep Programming Language series. In today's lesson, I want to do a little bit of a reminder of some different things that we've learned and combine them with templates throughout this series, because we don't want to forget all the old knowledge that we're learning just as we're learning the new stuff. It's kind of this idea of pushing out all the old stuff in your brain to fit in the new stuff. We want to actually mix and synthesize some of that knowledge. So anyways, with that said, let's go ahead and take a look at the Deep Programming Language webpage and give you just a few little reminders and some few new things on templates. So anyways, I'm going to go ahead to the language reference here. And we're going to go back to templates here as well. And where I want to take us is this template parameters section. So I'm just going to click on this, scroll through it, and then we're going to look at some examples and refresh ourselves on some of the things that we've learned earlier in this Deep Programming Language series, just to put things together. But these will also be some features that we're maybe used to if you've used templates in other languages like C++, for example, just passing in value parameters. So let's go ahead and take a look at template parameters. Let me actually get this nicely set up on half the screen. There we go. And the basic idea here is we're allowed to specialize the actual template parameters that we pass in. But that means we could also pass in just a string, for instance, inside of our template. So I want to go ahead and show what that looks like. And then we'll come up with some different ways to handle maybe common use cases with our templates. Let's see, let's go ahead and scroll through this as well here. And we'll see, just as I look through the type parameter deduction, which we talked about a little bit last time here, but you'll start seeing this show up here, this alias, the function name that we want to use, and then the actual instantiation of the template. So we'll want to hold on to that idea as well here. So just scrolling through this, there's some other interesting and neat things that we can do here. For instance, we can pass in this parameter here. So again, we'll talk about some of those things as we move forward. But again, just want to kind of scroll through here. The value parameters, again, we can just pass a string, for instance, and that's just something that I want to remind you of. You could put a type here. And we see this often, like, for instance, if you want a template parameter for a fixed size array. So when we look at structs, for instance, in the next lesson, we will go ahead and do an example with that. So anyways, let's go ahead and just take a look at a few of these different ideas here, refreshing ourselves on just some different programming things. And first and foremost, let's just go ahead and create a new function template, which we've learned about. So I'm just going to call this printer, for instance, and I just want to take in a string as the actual argument, and I'll pass in t here. It's not going to do anything really interesting other than it'll just write out whatever that string is. So let's go ahead and use the printer, and I'll go ahead and type out printer, and then hello from Mike here. Okay. And that's it. That's all the template is going to be. So I'll use rdmd and run it, and we'll see we get hello from Mike here. So that's literally taking this value here, this thing that can be evaluated at compile time. So let me go ahead and just put this as a template value parameter, which can be evaluated at compile time, and just paste it in. Okay, so that's the basic idea here. I mean, you could also think about maybe using this in another example. Like, let's go ahead and say, let's do a I'm going to do a printer this time. And let's go ahead and do a type here. But I want to actually perhaps specify that this has to be an array here. That's going to be the first argument. And then I'm just going to pass in an int for the size, for instance. And then we'll pass in whatever the array is going to be here. So let's just call this array printer. And again, you know, in practice, this probably isn't a function that we want to use, but prints a specific number of elements here. Okay. So again, this is going to, again, we're sort of saying, hey, the type of whatever we pass in, it must be an array. And we're just going to print out the first few things here. So basically, I'm just going to write a for loop here. I'm going to say for int I equals 0, I less than size, I plus plus, and we'll just write out here whatever the array is and the actual index of the element here. Okay, so let's go ahead and give this a try here. Let's go ahead and just create a array here, some data here, 1, 2, 3, 4, 5, and then we'll use our array printer, and we need to specify the type of our array, which holds integers here, and the actual size here. So let's just print out like the first 3 elements here in this case, and then I'll pass an array here. So let's go ahead and give this a try here. And it's saying, oops, template instantiation error. Let's go ahead and read this message. It So template instance array printer int 3 does not match declaration. Okay, because it's saying that this thing must be in array here, right? That's exactly what we're saying here. So what's the thing that we could use? Because I mean, this looks okay, right? This is an array of integers, but it didn't quite do the substitution that maybe I expected here, right? I'm saying that t is an array type here. So let's just go ahead and say the type of this array here. Okay, that's one way that we can do it. Oops, let's see. It looks like I've missed another bracket here. This needs to be a array. There we go. There we go. So of course I've got to make sure that I match the type here with this guy here. Okay, so we can't forget that. But now we are seeing that, well, I have the type here of the array, which is going to be, you know, in type, and I can template on that, or if I switch this to longs or floats or whatever it is, it's not going to matter. I don't have to. Now in this case, I'll just go ahead and do it here. Let's make sure that we're being precise. Now I can just put int and then the brackets here, and that'll also work here. But instead, you can use these little tricks here, right? Like the type of, which we've learned about before, which is a way of getting the type or instantiating other data types that are the same as, you know, whatever this variable happens to be. So that's getting to a little bit more of an advanced use case here, but again, something that's not all that tricky to do here. We're just specifying that it must be some sort of array type, and then here we're just using the value type here for the size here. Okay, so that's great here. Now let's say that we have some other function here. I'm going to go ahead and create one more templated function here, and I'm just going to call it again a, let's call it just something generic here. I'm just going to call it func here. It's going to take in some type here, and let's go ahead and have it just take in whatever that type is, and again, just write it out here. Okay, so we'll just write out t here. Now what might end up happening for us, for instance, is we might have this function here, and then we say an int here that I want to write out, and 5. Okay, so let's go ahead and write that out here. In fact, let's make this a larger number here, just so it kind of stands out in our print statement, right? 5555. So that's what we're printing out here. In practice, what might happen is, one, we might either develop specializations for how we want to print this out, right? Maybe we don't want to use primitive types and use some of our own custom objects. Or we might end up writing, you know, a bunch of different variations of this. Let's do 555, or let's do something like, let's do a floating point value here, 3.141526 or whatever. So something like pi here, right? And I mean, immediately it becomes a little bit of a annoyance to write these out. Now with D, as we recalled from the last time, D is smart enough that I can get rid of these parameters, and it'll figure out or deduce the type. Now, is that treating as a double or a float? Again, we might want to be, again, explicit. So hence why we would put float there and an F after there. So that's just a little bit reminder from last time. But my point is, what we can start doing is, if we want, we could write an instantiation, so an alias, and I'll just call this float func, which is going to be equal to the instantiation for the float here. Okay, so that'll be the basic idea. And then I'll do the textual substitution here. So then I can just use it like a more normal function here. I got to type this at 141526F here. And then if I run this here, again, it's going to do the exact same thing here as this function. But now I'm able to use this alias here. I can provide parameters. Again, let's do an example, just one last one for our array printer. Again, maybe you want like some sort of nice debug statement here. So let's copy this array printer. And I'm just going to call, or write an alias for this. I'm going to call this the first 3. Again, why you would do this, you know, I don't know. You'd have to think about it. But basically, it's just going to be an alias for whatever this function is. And let me clear out all of these guys here, just so we can see how to, again, set this up. And in fact, I'm going to have to be a little bit more specific when I'm using this alias, because we have to sort of know at compile time. So I'm going to call this first 3 int or something. It's going to take an integer array, 3 here, and then we can, again, call this basically first or same function here with just the argument without having to remember to do any of this type of stuff. Pass in 3, and this should do the exact same thing here. Meaning that we get 1, 2, 3, and then 1, 2, and 3. Okay, so that's the basic idea there with that, with these alias tools that we have. And these are actually going to be very useful for us as we do compile time programming. So it's just something that I wanted to bring your attention to. So just do a little review. Alias, or another name for, often a useful shortcut and can in some ways clean up our code. We also looked at value type parameters here for our templates, because we might want to just put in a fixed string or a fixed size like we did in this example with a little array printer. And then we looked at how we can sort of enforce some sort of type here, again being careful to also match that with our templated type here. Okay, so just a few things to look out for there. All right, folks, so with that said, make sure that you keep up with your lessons here. You can keep up with them on my site here, signing up for free in a distraction-free environment. Hopefully you enjoy that. And anyways, folks, thanks as always for your time and attention. Hopefully you enjoyed that. Let me know if you have other little tips and tricks here for working with templates in D, or perhaps other languages that we might want to translate over to D, and I'd be curious to see that. Alrighty, folks. Anyways, with that said, I'll look forward to seeing you in the next one.